I'm Kainton the Tech Pro, and I'm going to teach you how to build a classifier in Python from beginning to the end without no steps skipped. I've actually outlined all the steps we are going to follow to build this classifier right here in this website. The link is in the description box below this video. I've called this logistic regression in Python with Titanic dataset, but it's actually a classifier because a logistic regression model is actually a classifier. We are going to be actually building 3 different classifiers. One, we are going to be looking at decision tree classifier, random forest classifier, and gradient boosting classifier. Now, all the piece of code you need, the step-by-step is here in this website, my website, and you can follow it after now if you want. Right now, I'm going to recommend pause the video, open Jupyter Notebook in your system, and be able to follow this step-by-step because it's really going to be easy. I'd also like to remind you to subscribe to my channel if you've not subscribed to my channel. Subscribe so that you get nuggets like this. So in that case, you kind of motivate me to keep making this lesson for you. And if you have any challenges at all, you can leave it in the comment box below. Just below this video, you can leave a comment for me to let me know where you have some challenges, and I'm ready to help you. So hit the subscribe button and let's get started. Now, I'm going to kind of minimize this. Okay. So the first thing is that you want the Titanic dataset. So this is the dataset we are going to be using. If you are in this website, click on this link. You are going to have this website, this dataset downloaded. All right. Again, if you want to learn a bit about logistic regression, you also have the link here. Hit that link, and then it takes you to where you can learn about logistic regression. But for now, you can follow this lesson step by step. Let's build a classifier. All right. So let's first import all the necessary models. We are going to import pandas, numpy, and seaborn. So these are the 3 models we want to import, and I'm going to simply paste it right here, and we are sure. Right now the kernel is busy. If you place your mouse here, you can see kernel busy. So each time you see something like this, it means you need to wait for a couple of seconds for it to complete the operation. Alright, so the next thing we want to do is to read this dataset. So this is the code to read the dataset. Now I'm going to place each of the codes in different cells. Also know that when you see this field, okay, now kernel have completed the work. So now we are going to read this dataset. This dataset is right in my computer in my drive D, data Titanic. The CSV is a CSV file and is separated by space or tab. Alright, so in this case, if you are using this tab, then you have to specify the engine to be Python. Alright, so I'm going to just run it. Run. Alright, so we have read this dataset. If you will, or if you want, you can just view this dataset by saying pd.df. We call this dataset df.head, just to see how this dataset looks like. Now we are trying to predict who survived the Titanic. So when the Titanic crashed, who survived the Titanic? If we don't know who survived and you have the data of the passengers, we can predict who survived or who may have survived. This can be very important if you are boarding a cruise ship or some other transport. The analysis we are going to do kind of helps you know that at some point you may know that people that stay in first class in ships or almost survive, most of the time survive much more than people that stay in other classes. This is something we are going to talk about at a different time. So what I'm saying, in fact, data science and analysis is really something very important in life generally. These are data set. Now we see that we have a number of things. If we have text, for instance, we have name, we have sex, we have ticket, we have cabin, we have embarked. So this text data does not really help in data analytics. We are going to do something called data cleaning or data preparation or pre-processing. Something we can do to our data to clean up some values that does not help in our analysis. All right, so the first thing we want to do, we are going to drop some of these columns because they don't contribute anything to the analysis. For instance, the name column does not contribute anything. The name of the ticket does not contribute anything. The cabin, also we are going to drop it. Later we can see that it helps, but for now there are a whole lot of things in this cabin that we have C85. Later we talk about how to convert strings, extract the number from the string. But for now, let's drop it to make sure that this analysis remains simple for now. So to drop 3 columns, I'm going to simply copy and paste the codes to drop the cabin, the cabin, the ticket, and the columns. All right, before I drop it, I'd like to teach you that if you say df.info like this, you'll be able to get the information about everything in the data set. Now you can see that the class is integer, the name is object. You see some of them are object. These ones that are object is the problem. All right, these objects are the problem. All right, so but eventually we are going to drop them. So let's drop some of these columns. For instance, we are dropping the name, the cabin, and the ticket because they are not necessary for now to keep this analysis simple. So let me run this code. I'll drop them now. So if I check again df.head, you can see that they are all gone. All right, they are all gone. Of course, df.head gives you the first 5 items in the data set. If you want more than 5, maybe you want 10 or 2 or 3, you simply place it inside here. In this case, you have 10 items from the first 10 items. So let's just keep it simple at this point. All right, so now we want to now get information about this data set. There are some places we have null values. Null values is a problem because if there are null values, then most likely it will hamper the analysis we do. So if I say df.info, that will not help. So let's use sb.heatmap. So sb.heatmap helps us to see, or we can use df.info for now, after we use the heatmap. So we want to know where we have null values, and if I run it at this point, you can see that it says 156 entries. Okay, we have 0 to 155, but if you look at the age, you can see in the age that we have only 126, meaning that many of the entries are null for the age column. Okay, also look at the embarks. One of them is null because we only have 155 right there. And also we have the sex here to be object, meaning that it's not a number and it's going to be a problem. We are going to clean it up to see, but we are not going to drop it. I'm going to show you how to clean it up. Embarked is an object as well. So sex and embarked, age, these are the 3 things we are going to work with now to help us. Now, using sb.heatmap. So heatmap is a module, it's a function in Cbond that helps you visualize the data to see where you have null values. So if I run, okay, heatmap, you just say df.isNull. So if I run it at this point, you can see that we have something called a heatmap. I'm going to just enlarge a bit. Okay. So here you can see that under the age, we have many null values. Also in embarked, we have maybe 1 null values there. All right. So the next thing we want to do is to do something called interpolation to make up for the missing values in age. Interpolation means you can deduce the missing value by interpolating existing value. There is the explanation I'm reading right now. For example, if we have a series 1, 3, 4, question mark, 6, 8, what is this question mark? It's likely to be the number halfway between the one on the left and the one on the right. That is called interpolation. And in Python, we can easily do interpolation by simply using .interpolate function or method in this very column. So let's interpolate. I'm going to just copy and paste. For you, I recommend instead of copying and paste, type it out by yourself because the more you type, the more you are getting used to it. All right, so I'm going to paste. Now we are saying that we are going to interpolate the missing values, all the missing values for age. We are going to interpolate it and replace those missing values with an interpolated value gotten from existing values. So I'm going to interpolate it at this time, and I'm going to do the heat map again, sb.heatmap. Let's just make sure that there is no null values left. So if I do a heat map again at this time, you'll see that there are no more null values in age. We've interpolated all of them and replaced these missing values with interpolated values. Except that we have for embarked, we have one missing value. But we still have a problem. We can drop missing values for the embarked. Seems there are one. So let's check how many missing values we have. df.info helps us to see how many missing values. So here we have one missing value in embarked, and you can see 155, but there are 156 items. So in that way, I'm simply going to drop the missing values. Maybe it's only one. So let's drop it instead of trying to do any other thing. All right. So if I say df.drop_na, da.drop_na means drop not available. Na means not available, and I'm going to run it at this point. So if I do the heat map again, or I can say df.info, it actually drops that record. So we only have 155 items left. So let's see. Yeah, so you have 155 items left. So you drop that row where there is one single missing value. Okay, so we now need to worry about the sex, because if I say df now, df.head, let's look at the first 5 items. You'll see that we have embarked, we have values that are not numeric. For the sex, we have values that are not numeric. We need to find a way to convert categorical values to numbers. So if we have male, female, we want to convert it to 0 and 1. If we have embarked, we have SCR or something, we have to convert to maybe 1, 2, and 3, and things like that. So to do that, I'm not going to spend time to explain it, because I've already explained it in a different video. So if you click on this link, it will take you to a video that explains how to convert categorical values to numeric values. So in this case, for sex, male, female, is going to be 0 and 1. So first, I'm going to create dummy variables. Let me paste it, then I'm going to explain it for you. So first, we are creating dummy variables for embarked and sex. So these dummy columns are simply in another column, this time with categorical values. The function that says pd.getDummies converts categorical values to numeric. So we have embarked column dummy is a dummy column for embarked. The sex column dummy is dummy column for sex. Interestingly, what we have for sex column is 2 different columns. So if we have for male and female, it creates 2 different columns. It's kind of counterintuitive, but we are going to, I'm going to run it at this time. Okay. Now these dummy columns we've created, we are going to append it to the data set, right? And later we delete these other ones that are not numeric, right? The dummy columns now are numeric values. We are going to append it to the data set and then delete the categorical values that are already existing. So, we are going to use the concatenate. So I'm going to just copy and paste. So now, but before I do this, let me just kind of show you what is inside these columns that we have here. So if I check embarked column, dummy dot head, just for you to see what is there. So embarked column dummy dot head, we have three different rows created from one single categorical value because there are three categories there. But it's not a problem in data analysis. You can use this to replace this one single categorical value because now we have not categorical value, which is numeric. All right, let me take it out. All right, so let's now add this dummy columns that are now numeric. Let's add it to the original data set. I'm going to run this code. And now if I look at my original data set, df.head, you can see that we have 2 additional columns and 3 additional columns for sex and embarked. Now you can see male, female, we have 0, 1, CSQ represent for embarked. We have 3 different columns. It's okay. Later you can talk about deleting maybe 2 of these columns and leaving only 1. But for now it's okay. You don't have to worry about it. We simply have to delete the categorical values columns that are only text. So now we can now drop the sex column and the embarked column. So I'm going to use df.drop. So this is how it goes. Drop the sex and embarked column because they are non-numeric. So the axis of along to drop is the vertical axis. That's why we say the axis is 1. All right. So now at this point, if I say df.info, you'll see that we have everything to be numeric. Now we have everything to be numeric and it's okay. Now I have additional column CSQ, but it's okay. The interesting thing or the important thing for analysis is that everything now is numeric and we can proceed with our data analysis. So now we've completed our pre-processing or preparing our data. Now on to analysis, and of course you know that we need to separate this data set into X and Y because we are trying to predict Y from X. So given X is now all the features and Y is what we are trying to predict, which is survived. So X will now be only one column is equal to the X is equal to all the values, while Y is what we are predicting, which is survived. So that is what we do here. I'm going to copy and paste it as well. So here we have X is equal to df.values. We are taking all the data. All the X now is containing all the data. Y contains only one column, which is survived. Now X have to be, of course, X is everything now, but we need to remove that survived column from X. So to do that, we have it right here. So we have np.delete. Let's see. So what are we deleting? Okay, so let me run these first. Okay, so want to delete from X, this is our data set. We want to specify the column to delete. I'm actually going to specify, let me just check the syntax for delete because now it's going to, we have, okay, so I think we are correct. This passenger ID is column 1, column 0, survived is column 1. So we are going to take out survived from X. So 1 is okay, but there's also a way to delete based on the name of the column. Let me try it because you never can tell. We learn something. So just remove this. So insert cell above. Okay. So let's see. So X equal to mp.delete. From X, I'm going to delete the column is survived. And axis equal to 1. Let me see if it works. Okay, so it doesn't work because it says invalid literal. It doesn't work. So I don't know if I'm to enclose it in maybe square brackets. Maybe, I don't know. So if it doesn't work, we use the one we have already. So let me run it. It also doesn't work. So let's just forget about it. So we are going to delete based on the column index. We have survived this column index of 1. So let me just delete. Good. So if you now check for x dot head, you'll see that x does not have survived. So if I run it, you can see that. Okay, so now this is, it doesn't work. So okay, so let's see. I don't know if this works. Okay, so this is the numpy array. Okay. Anyway, let's leave this for now. So we separated the data set into x and y. What I was trying to do, that there's a way to get around it, but let's keep it simple for now. We're now going to split our data set into training data set and test data set. We have to use 70% of this data for the training and 30% for testing. So that's a good way to split data. So the training data set will have the labels, while the test data set will have only the features, because using the test data set is what you are going to use to predict, to make prediction. Let me shift this a little bit up. So to split your data set, you use something called the function called test train split. Specify the x values, specify the y values, and specify the size of split and the random state. Up till today, I don't know what this random state exactly is all about. If you know, please let me know in the comment box below. Alright, so if I run it at this point, so now we have 4 different sets of data. The training, the X training data set, the Y training data set, Y test, and Y train. Alright, so now comes the big thing we want to do. Now we are going to build a classifier. We are going to use this classifier. We are going to use our training data set to train our classifier, and then we are going to use our classifier to make a prediction. So I'm going to copy and paste, then I'm going to explain to you what is happening. Actually, what does it mean to build a classifier? First, we need to import the tree module from sklearn. So tree is what you use to build a decision tree classifier. So this line is simply what you need to use to build your classifier. So you simply say tree.decision tree classifier and specify the max steps. Of course, you know that the depth of a tree, of course, if you have a tree data structure, how many steps will it be? So that's where we have maximum steps to be 5. So the next thing we want to do is to now use the classifier to train our model. So in this case, we have this one, we build our classifier, build, train, and in this case, make prediction. So using our classifier, we are going to make prediction given the test data set, and using this test data set is going to predict the values for y, right? If it predicts values for y, those values will be compared against the actual values for y, which is in y test, right? Because that is how it is. Y test is actual values, what we expect. X test is the values we input into the classifier, take these test values, predict y. After predicting, we compare it with the actual values of y, and then we check how well it performed. Alright, so before now, we talked about the performance of the classifier. Meanwhile, let's run this and let's see. So it has a score of 78. So a score of 78.7% is not bad. It's a fairly good classifier that we've made. Now, if you want to see how to display the confusion matrix, we are going to talk about this a little later, because confusion matrix helps you to see how many wrong classifications were made, how many good classifications were made, how many, yeah, so it just tells you how many false positive, false negative, true negative. That is what confusion matrix tells you. If you want, you can also look at it when I discuss logistic regression in the link in the description box below. But after, if not, in the next series of lessons, I'm going to make a more complex classification class where I'm going to now go further with this. Alright, so we built a decision tree classifier. It did a bit well. If it's a fairly okay model, because we have 78.7, but for critical system design, this is really not a very good score of 78.7. Now we will now try to build another classifier using random forest. We are going to build a random forest classifier. One thing is that if you know how to build a classifier using one classifier, you can build any other classifier. All right, so I'm going to, in this case, we are now building another classifier. This time we are building a random forest classifier, and the random forest classifier is available in the assemble module in the sklearn module. So let's say build this classifier and see how it works. I'm going to run. So this classifier performs similar to the first one. I don't see any difference from the first one. Exactly the same thing. So, okay, let's see. So exactly here, okay, exactly the same thing. Not quite. It seems that the random forest gave us not very good classification. Let's change the number of estimators to 50. I run it now. Oh, 50 gave 100. The same thing. Let's change to 100. And it's giving us exactly the same thing. Okay, so the more we run it, the more the accuracy improves. So here we have 80% now, which is fairly okay. So we have the random forest classifier. When you train the model for a number of times, you have better classification. Let's now use something called the gradient boosting classifier, which actually theoretically should be better than these other two classifiers. But there might be a catch. If your data set is very small, then maybe it's not going to give you a very good performance, like what I have in my website. So let's do a gradient boosting classifier. So I call it GBF classifier. So let's run. Boom. 72. Not very good. So let me run again to see. Okay, so 72, not good. So you can see that this was the limiting factor seems to be our data set. But there's something we can do. We can use a hyperparameter to tune this classifier. This I'm going to discuss in a different video. So a hyperparameter is used to specify the parameter used to tune the classifier to specify how many times the classifier is going to iterate during the training. I'm going to make a different class on this. Alright, so okay, so n estimators we specify to be 50. Alright, so let's see how gradient boosting classifier is going to perform. Run. Okay, 74.4. So we tuned this classifier and it improved from 72 to 74.5. Okay, so if I rerun, we have the same thing. We run again, we have exactly the same thing. So if we change the number of if we change the hyperparameter to 100, let's see, it doesn't improve. Let's reduce it to 40. See if we can get some kind of trade-off. So 74.4 simply seems to be the best this classifier can do. Alright, so this is how to build a classifier. This is a quick way to build a classifier, but there are other questions you might ask. Then what then do we do with these classifiers? What does it tell us about the data? How do we get more information about the data? Now I'm working on a different lesson. I'm going to just show you right now. This one is actually a bit more complex than what we've been doing before, because in this case we are actually going to get some insights from the data. Yeah, go down a bit, you can see age group sizes of survival count based on male or female, survivors by the class by the class by the passengers class, and so on and so forth, until so here is actually a bit complex. I have randomized SGB classifier I use here. Yes, so there are a whole lot of things I'm working on. I'm going to present after now, but I'm trying to find a way to make it very, very easy for you. I'm going to stop here. If you have any questions, let me know. This website is in the description box below this video, so feel free to visit and follow the procedure. Also, feel free to subscribe to my channel. If you've not subscribed, hit the subscribe button below, leave me a comment, and also share this video among your friends if it has helped you. And we see you in the next lesson.